So the Bitcoin price is pretty volatile, right? But what if I told you that underlying those crazy ups and downs is a simple mathematical pattern that you can use to predict Bitcoin's future growth? It's called the power law. You might have heard of it. And in this video, I'm going to break down how it works, what it is, why it matters, and how you can verify and derive it for yourself. So the Bitcoin power law is a way to understand how Bitcoin's price has changed over time, using a specific kind of mathematical relationship called the power law. So what is the power law? Well, a power law is a simple relationship between two variables. It shows how one thing changes as another thing changes. And in Bitcoin's case, it's showing how the price changes relative to how the time changes. So it's a way of assessing Bitcoin's growth over a long period of time. So the power law is a good way to assess the long-term trend in the Bitcoin price. Instead of focusing on those daily ups and downs, the power law focuses on the bigger picture, smoothing out those daily fluctuations to see the general trend over many years. So while it's not perfect, this pattern gives us a good way to estimate the Bitcoin price in the future and when it might hit key milestones, such as reaching $1 million, for example. Okay, so here I am in Google Sheets, and I've got some data here. In the first column, I've just got the date from 1st of January 2011 all the way till today. The next column, I've got a numerical representation of that date. And I've just taken the number of days from when Bitcoin started, which was the 3rd of January in 2009. And that was 728 days until 1st of Jan 2011. And the reason I need that is because you can't run a regression on a date value. You also can't take the logarithm of a date. So we're just taking a numerical representation, in this case, the number of days since Bitcoin began. Okay, and then the third column, I have the actual Bitcoin price. All right. So if we plot that on a regular chart, it looks like this. You're probably quite familiar with this chart. This is the actual Bitcoin price over time. And as you can see, it's very volatile. We've got these crazy run-ups here, and then these crashes, and then these peaks and crashes and peaks and crashes. And regular people, well, a lot of regular people look at this and say, wow, Bitcoin is so volatile. I don't want any part of that. I'm not going to invest. It's a bubble. It's going to pop. All of that kind of stuff. Now, the mathematicians and the people who think a bit more deeply looked at this and thought, I wonder if there's an underlying pattern to this data. I wonder if the long-term trajectory of Bitcoin can be modeled somehow. And they found that indeed it can be. And in fact, the price appreciation follows a power law. So how did they know this? Well, they just took this chart and they took the logarithm of the x-axis and the logarithm of the y-axis. And suddenly the Bitcoin price looked like a straight line. So this is the chart. Exactly the same data. We're just seeing the time as a logarithm and the price as well. So when you get a straight line like this on a log chart, you know that the data is following a power law relationship. And in the case of Bitcoin, the fit is actually incredibly good. So we have this R squared value of 0.946, so 0.95. If you haven't done statistics, R squared is just a metric that you use when you're running regressions to see how well your line fits the data. So in other words, yeah, so the R squared goes from 0 to 1, and the higher the value, the better the fit. So in this case, we have like an incredibly good fit for the data. And essentially what this is saying is that 95% of the variance in the Bitcoin price can be described by movements in time, which is quite incredible. And the reason why this is so significant, and the reason why mathematicians and physicists are interested in this, is because you wouldn't expect to get such an incredibly good fit from something like the Bitcoin network, which is this huge, massive global network, and there's, millions of different variables that go into how the network grows and the price appreciates, right? But it turns out that all you need to know is time to understand how the price grows and how the network grows. So that's quite amazing. Oh yeah, so you probably have a friend who's told you that Bitcoin is a bubble and it's going to pop and the price will come crashing down. Well, the power law pretty much shows that that's not the case at all. So I'll talk more about that a bit later. But what else can you do with this? Like, what are some of the practical applications? Well, one of the obvious things you can do is predict the future Bitcoin price at a certain date, right? So the model is very simple. The only variable is time. So you can plug in a time value and derive a Bitcoin price prediction. So how do you do that? Well, you just take this line here, this power law trend line, the orange one, and you just extrapolate it off into the future. Um, so let's go ahead and do that. So I've got the same data here as I was working with before. I've just added another column here on the right, which is the power law line. And I've taken the equation for that orange trend line and I've just plugged it in here. So the equation is 1.25 multiplied by 10 to the minus 16 multiplied by time to the power of 5.52, which is the power law index. So one thing to note quick is that this probably differs slightly from some of the power law models you've seen before, because, for example, I'm progressing based on daily price values, and I'm looking at calendar time, whereas some of the other models use monthly price values and they look at block time. So there's some slight differences there. But this is more or less, what it is, and it's a pretty good approximation. Okay, so what I've done is I've taken this power law here and I've just dragged the formula down and I've extrapolated it way into the future so we can kind of see where the price is going. So this is what it looks like. I know what you're going to say. This looks like a different chart than this one. And I can assure you it's exactly the same, other than we're looking at it in log linear terms. So the y-axis here is in log terms, but the x-axis is in linear terms because we want to preserve the actual date values here. All right, so if we follow this line, we can kind of try to estimate where the Bitcoin price will end up. And for example, we can look at $1 million here and follow this line here, and we'll see that the model crosses the $1 million mark just before 2035. So in about 10 years' time. So why does it matter that the Bitcoin price is increasing as a power law of time? Well, to answer this question, I'm going to quote Harvard astrophysicist Stephen Perrineau, who says, "Power laws are more stable than exponentials, which is the finance professional's default way to analyze stocks. Exponentials tend to run away and then crash. There is a reason why nature uses power laws for gravity, electromagnetism, and in many emergent phenomena. Exponentials are seen in radioactive decay, the essence of instability." So the power law tells us that Bitcoin is growing steadily over time, whereas an exponential will grow at a very rapid rate. It's not sustainable. Eventually it'll come crashing down. But a power law is more gradual, more steady, and more robust. And this is exactly the type of growth you would want to see from the world's next major monetary asset. Okay, so let's talk about some of the shortcomings of the Bitcoin power law. So one of the obvious ones is that it sort of increases forever. You can extrapolate the power law into the future and you'll find that the Bitcoin price just keeps increasing. Now, that's probably not that realistic. We know that a lot of technology follows sort of an S curve when it comes to adoption. So that is a definite shortcoming. But there's no reason to think that Bitcoin will stop following the power law pattern anytime soon, especially because it has followed it for the last 15 years. Another shortcoming of the model is that it's based on historical data. And this might not hold into the future, right? I mean, there's lots of potential things that can impact the Bitcoin price, including geopolitical situations, other financial instruments, world wars, crazy things like that. And obviously, this model doesn't take into account any of that stuff. So it is quite simplistic in that way. Okay, I hope that was interesting. I hope that cleared up any questions you might have around the Bitcoin power law. It's not some sort of mathematical marvel. It's incredibly simple, and anybody can verify it and derive it. In fact, the Google Sheet I was using, I've put the link to that in the description. You can go ahead and check it out, make a copy, mess around with the data, see how I built those charts, and get an idea for exactly how the power law works. So thanks for watching this video. If you have any suggestions for future content, please leave a comment below. Please give a like and a subscribe if you thought this was helpful, and I'll see you in a future video.